For the next set of notes, we're going to look at evaluating a function based on an input value. For example, given a value of x to use, or the independent variable value, what would the dependent variable value be? Or, given the result of the function, the output, or the value of the range, what would the domain value be, which maps onto that range value? So basically you're going to be replacing one variable by a value and solving for the other variable. So let's look at some examples. We begin with the parabola. So if f of x equals x squared, let's look at evaluating this function. So suppose that x equals 2. Then we say that the function value at x equal to 2 would be 2, which replaces x, raised to the second power, which would be 4. If we said, what about x equal to negative 5, then we say that f evaluated at negative 5 equals negative 5 squared, which again is negative 5 times negative 5, and that results in positive 25 for the result. Now let's find the value of x for which the function would evaluate to be 16. So we say that f of x, when I put the number in for x, should be 16. Well, what number do I have to put into the function? So then we're saying that 16 equals x squared for what particular value of x? In this case, when we solve, we take the square root of each side. So the square root of 16 equals the square root of x squared, so that x could be either positive or negative 4. Now in some cases your domain may be limited, in which case only one of those two answers is possible. So keep that in mind as you move through examples and look at different scenarios. Next, let's consider our function where we had g of t equal the square root of t. And suppose we want to evaluate this when t takes on the value of 4. Here, g evaluated at 4 would be the square root of 4, which is 2. Now remember earlier, in the first set of notes, we actually defined the function as just the positive square root. So as a result, we'll only take positive 2 as the answer instead of both positive and negative 2. What if t turned out to be 6 1/4? In this case, what would our function evaluate to be? Well then, what we would do is say that g evaluated at 6.25 just means takes the square root of 6.25, and that actually turns out to be 2 1/2. Now let's say that we wanted to solve and say what value of t produces g of t equal to 90. So 90 equals the square root of t is true when t is what number? Well, basically you square both sides, so 90 squared equals the square root of t, quantity squared, would tell you that t equals 90 squared, or 8100. The next function we looked at was this ratio where we had two linear functions. In the numerator we had 15x plus 2, and in the denominator we had 3x minus 1. What would this calculate to be if x equals 1? Well, in this case, we plug the value 1 in wherever there's an x. So 15 times 1 plus 2, so that would be 15 plus 2, or 17 for the numerator. And in the denominator, we have 3 times 1 minus 1. So that would be 3 minus 1, or 2. So 17 halves, or 8 1/2, or 8.5 would be the solution. Next, for what value of x does the function f of x equal negative 3 1/4. So this is going to require some algebra. So what's the first thing we're going to do? Well, let's go ahead and rewrite negative 3 1/4 as an improper fraction. So 3 times 4 would be 12. 12 plus 1 is 13. And we've got negative 13/4 equals our function. Then we have negative 13/4 times, and we're distributing the denominator. So 3x minus 1, we multiply by on both sides, and then simplify. When we do that, on the left side, we would get negative 39/4 x plus 13/4 equals, and then on the right side, we're left with just the 15x plus 2. Then we could subtract the x term from the left side. So subtracting a negative is adding 39/4 x. And then for the 2 on the right side, we want to get rid of it. So we're going to subtract 2 from both sides. And we get the equation here. And then when we simplify, the constant term turns out to be 5/4, and then the term with the x, the coefficient, is 99/4. And then to solve, I would multiply by the reciprocal of the coefficient in front of x, so that would be 4/99 on both sides, and then simplify, and I get that x would be 5/99. What if we wanted to solve for the value of x so that f of x actually equals positive 3 1/4? So notice back here, we looked at when f was negative 3 1/4. Now we're looking for when f of x is positive 3 1/4. So again, we began by writing as an improper fraction. So we set the two things equal, write an improper fraction, multiply through by 3x minus 1 and simplify. When we multiply that out, we get 39/4 x minus 13/4 equals 15x plus 2. So this time we're going to subtract 39/4 x from both sides, and we're going to subtract 2 from both sides. And then we're going to simplify. And when we simplify, we get negative 21/4 equals 21/4 x. So then multiply through by 4/21, and you see that x equals negative 1. What about the function when f of x was the square root of 10 minus 5x? What would the function be evaluated at if x is 3? Well, in this case, if we plug in 3, we get the square root of 10 minus 5 times 3, which is 10 minus 15 underneath the radical, but that would be the square root of negative 5. And there's really no real number answer to this equation. So we say that there is no answer, there is no real answer. Oops. What if we want to calculate f at negative 3? So in this case, we want x to be negative 3, plug into our equation, and what will we get as our solution? Well, in this case, we find that 10 minus 5 times negative 3 is the square root of 10 plus 15, or the square root of 25, which we would write as 5. Now here I'm again assuming the range is positive real numbers. What if f is negative 5? What would the function evaluate to? In this case, whoops, I have an extra number in there. So 10 minus 5 times negative 5 is 10 plus 25, or the square root of 35. And in this case, we'll just leave it as the square root of 35 instead of trying to write it as a decimal equivalent, which would only be an approximation. Basically, this is a little bit less than 6. And again, we're assuming the range is positive. For what value of x would the function evaluate to be 4? So again here, we're going to use some algebra and solve. So we set 4 for the function value equal to the square root of 10 minus 5x. In this case, we're going to square both sides, so we get 16 equals 10 minus 5x, so we've lifted the radical. And then we say 6 equals negative 5x, so divide through by negative 5, and we find that x equals negative 6/5, or negative 1.2 would be the solution. Hopefully this gives you an example of how to solve both when you're given f of x values or an x value and asked to locate the other numeric answer.